Welcome to your practice test 4. Next section. Learn neural network fundamentals. Question 1. The Badam optimizer is popular because it combines which two ideas? The correct answer is V. Badam maintains exponentially decaying averages of past gradients, momentum, and squared gradients, adaptive per parameter step sizes, giving fast, robust convergence with little tuning. Question 2. A team observes loss becoming rarer with huge gradient values mid-training. Which technique most directly addresses exploding gradients? Option 1. Gradient clipping. Option increasing the batch size to the entire dataset. Option removing the loss function. Option switching from over to 1. The correct answer is V. Gradient clipping rescales gradients whose norm exceeds a threshold, preventing the destabilizing huge updates that cause exploding gradients and rarer losses. Question 3. Ross entropy loss is the standard choice for which type of task? Option classification with probabilistic softmax outputs. Option predicting a single continuous house price. Option voting a list of numbers. Option compressing an image file. The correct answer is V. Ross entropy measures the divergence between predicted class probabilities and the true distribution, making it ideal for classification and next token prediction in hit miss. Question 4. Which techniques help stabilize and speed up deep neural network training? Select all that apply. Option normalization layers, batch or layer norm. Option Vensible weight initialization, for example, caviar by phi. Option when appropriately tuned learning rate and warm up by schedules. Option wetting all weights to 0. The correct answers are V and normalization, proper initialization, learning rate schedules, and gradient clipping aid stable training. Initializing all weights to 0 makes neurons identical and prevents learning. Next section. Transformer architecture and attention. Question 5. In scale dot product attention, why are the dot products divided by the square root of the key dimension? Option A. To prevent large magnitudes that push softmax into regions with tiny gradients. Option to convert logits into tokens. Option to reduce the number of parameters. Option I to encrypt the attention scores. The correct answer is V. Without scaling, dot products grow with dimensionality, making softmax extremely peaked and gradients vanishingly small. Dividing by squirt underscore k keeps scores in a stable range. Question 6. In large transformer layers, the dominant share of parameters typically resides where? Option A. In the attention and feed-forward weight matrices across the stacked layers. Option in the positional encoding table only. Option in the tokenizer's rejects rules. Option and in the firmware. The correct answer is V. Those parameters live in the per-layer linear projections, the attention sub by A by output matrices, and the large feed-forward layers, multiplied across all transformer blocks. Question 7. Why does standard self-attention become expensive for very long sequences? Option A. Its time and memory cost grows quadratically with sequence length. Option It cannot process more than 10 tokens. Option It requires a separate model per token. Option It disables the The correct answer is V. Full self-attention compares every token with every other token, giving an compute and memory in sequence length n, motivating efficient by sparse attention and clash attention. Question 8. Which of the following are valid approaches to encoding token position in transformers? Select all that apply. Option A. Sinusoidal positional encodings. Option A. Turned absolute position embeddings. Option rotary position embeddings. Row 1. Option I. Moving position information entirely with no replacement. The correct answers are V and sinusoidal, learned absolute, Yokon, and Madhai. We all inject position information. Simply discarding position leaves attention order agnostic and degrades performance. Next section. Third fundamentals and tokenization. Question 9. Had to scaling loss for is described. Option A. Predictable improvements in loss as model size, data, and compute increase. Option how to physically scale a with clock speed. Option the maximum file size of a dataset. Option how to resize images. The correct answer is V. Killing laws empirically relate model loss to parameters, dataset size, and compute, guiding how to allocate resources. For example, Hinchillas compute optimal data by parameter balance. Question 10. That characterizes a mixture of experts do not Option a router activates only a subset of expert subnetworks per token, increasing capacity without proportional compute. Option every parameter is used for every token equally. Option it has no trainable parameters. Option it can only run on omnis. The correct answer is V. Lunar layers contain many experts but route each token to only a few, so the model has very high total parameter count while keeping per token compute active parameters lower. Question 11. How does beam search differ from greedy decoding? Option A. Beam search keeps several candidate sequences at each step to find a higher probability overall output. Option A. Beam search always sets temperature to 2. Option A. Greedy decoding explores more paths than beam search. Option A. They are identical algorithms. The correct answer is V. Greedy decoding picks the single most likely token each step. Beam search maintains the top k partial sequences, beams, often yielding more globally probable outputs at higher cost. Question 12. Which techniques can reduce our memory usage during the inference? Select all that apply. Option A. Date quantization, for example, 8 by 4. Option A. Page depth cache management. Option A. Using a smaller or distilled model. Option A. Increasing the model's parameter count. The correct answers are V and A. Quantization, efficient YAP cache paging, distillation by smaller models, and memory efficient attention reduce inference memory. Widening parameters increases it. Next section. Prompt engineering. Question 13. In the EVAC prompting pattern, the model interleaves what? Option A. Reasoning steps with actions such as calling tools and observing results. Option A. Only final answers with no reasoning. Option A. Training and evaluation phases. Option A. Tokenization and detokenization only. The correct answer is V. EVAC, reason plus VAC, prompts the model to alternate between reasoning traces and actions, for example, search or tool calls, using observations to inform subsequent steps, useful for agents. Question 14. What does the self-consistency technique do to improve chain of thought results? Option A. Damples multiple reasoning paths and takes the majority vote answer. Option A. Sets temperature to 0 and stops. Option A. Removes the reasoning step. Option A. Trains a new model each time. The correct answer is V. Self-consistency generates several independent chain of thought samples and aggregates them, majority vote, improving accuracy on reasoning tasks over a single greedy chain. Question 15. For a complex multi-step reasoning task, which prompting strategies are appropriate? Select all that apply. Option A. Chain of thought prompting. Option A. Self-consistency sampling multiple chains. Option A. Decomposing the problem into sub-questions. Option A. Telling the model to answer instantly with no reasoning. The correct answers are V and A. Chain of thought, self-consistency, and problem decomposition help with multi-step reasoning. Forcing an immediate answer with no reasoning typically reduces accuracy. Next section. Fine-tuning to rev and pineapple. Question 16. A team wants to adapt a 7.0 PRMETR model on a single hub with limited memory. Which approach is most suitable? Option A. To rev 4BI to quantize base model with two rev adapters. Option full parameter fine-tuning of all 7.0 weights. Option A. Training a new 7.0 model from scratch. Option A. Only changing the tokenizer. The correct answer is V. Rev quantizes the frozen base to 4BI T and trains small to rev adapters, drastically cutting memory so large models can be fine-tuned on modest hardware. Question 17. How does supervised fine-tuning differ from RAV? Option A. RAV imitates label demonstrations. RAV optimizes a reward learned from human preferences. Option A. RAV needs no data. RAV needs no model. Option A. They are the same procedure. Option A. RAV only works for images. The correct answer is V. RAV trains the model to reproduce human-written target responses. RAV goes further by training a reward model on preferences and using AI to push outputs toward what humans prefer. Question 18. Which are valid reasons to fine-tune rather than only prompt and her? Select all that apply. Option A. Do enforce a consistent output style or format. Option A. Do teach a specialized skill or domain vocabulary. Option A. Do reduce prompt length by internalizing instructions. Option A. Do inject facts that change every hour. The correct answers are V and A. Fine-tuning suits consistent style, specialized skills, and shorter prompts. Rapidly changing facts are better handled by retrieval, not repeated fine-tuning. Next section. Python libraries for the miss. Question 19. That problem does Repeat with Velia primarily solve? Option A. Memory efficient large scale distributed training by partitioning optimizer states, gradients, and parameters. Option U. Mirroring interactive dashboards. Option H. Narrating audio. Option A. Nerving static websites. The correct answer is V. Deep repeats the assured optimizer states, gradients, and parameters across devices to cut per urban memory, enabling training of very large models efficiently. Question 20. That is yet again a machine learning workflow. Option A. One open framework agnostic format for representing by exchanging trained models. Option U. Urban brand. Option A. Type of activation function. Option N. A database query language. The correct answer is V. Yet open neural network exchange lets models trained in one framework, for example PyTorch, be exported and run in others or in optimized runtimes like ERG Runtime and NCA. Question 21. A service must serve an open source day at high throughput with low latency. Which tools are most appropriate? Option A. NVIDIA or NCA with written inference server. Option U. Matplotlib and Weber. Option A. Pandas and NumPy alone. Option A. Word processor. The correct answer is V. High throughput tray serving uses engines like NVIDIA or NCA-GENL, continuous batching, page lab cache, often behind written for production deployment and scaling. Question 22. Which libraries by frameworks support distributed training of large models? Select all that apply. Option 1. VPP. Option 2. Legatron. Option PyTorch fully boarded data parallel. Option A. Microsoft Paint. The correct answers are V and Deep repeat, Legatron PyTorch and Accelerate enable distributed by large model training. Paint is unrelated. Next section, ABU Hilo and training attack. Question 23. Within the Hilo framework, what is the Legatron-based component primarily used for? Option A. Pre-training and scaling large language models with model parallelism. Option A. Rendering user interface widgets. Option A. Compressing images. Option A. Managing email lists. The correct answer is V. Hilo integrates Legatron-style tensor and pipeline parallelism to pre-train and scale large transformer models efficiently across many hubs and nodes. Question 24. Then NCA applies AI-8 quantization. What is calibration used for? Option A. Determining appropriate scaling factors so low precision inference preserves accuracy. Option A. Increasing the model's parameter count. Option A. Training the model from scratch. Option A. Encrypting the weights. The correct answer is V. AI-8 calibration runs representative data through the model to compute activation ranges by scales, mapping COCO 3, 2 values to AI-8 with minimal accuracy loss. Question 25. That is the role of WAP-Inc in multi-hub systems. Option A. High bandwidth interconnect enabling fast hub-to-hub communication. Option A. Tool for labeling datasets. Option A. Python plotting library. Option A. Model file format. The correct answer is V. WAP-Inc provides much higher hub-to-hub bandwidth than GOE, accelerating the gradient by activation exchange that distributed training and large model inference depend on. Question 26. Which ABU tools are used in the data preparation and training stages, not just inference? Select all that apply. Option 1. Hilo data curation. Option A. ABU by data processing. Option A. Legatron-style parallelism training. Option A. Written inference server serving. The correct answers are V and Hilo AV and Legatron support data prep and training. Triton is specifically an inference serving system. Next section, Triton NCA and E deployment. Question 27. Triton's instance groups by concurrent model execution let you do what? Option A. Run multiple instances of a model in parallel on one or more hubs to raise throughput. Option A. Train the model on multiple datasets. Option A. Automatically relabel data. Option A. Reduce the number of model parameters. The correct answer is V. Instance groups let Triton host several copies of a model concurrently across hubs by hub, improving utilization and throughput for parallel requests. Question 28. That is speculative decoding in inference. Option A. A small draft model proposes tokens that the larger model verifies, speeding up generation. Option A. Randomly guessing the final answer with no model. Option A. Training two models simultaneously. Option A. Disabling the YAP cache. The correct answer is V. Speculative decoding uses a fast draft model to propose multiple tokens that the target model verifies in parallel, accepting correct ones, reducing latency without changing outputs. Question 29. A production day endpoint must lower its P99 latency under heavy load. Which combination is most directly helpful? Option A. Quantization plus continuous batching and a page job cache. Option A. Increasing model size and disabling batching. Option A. Serving requests strictly one at a time on one. Option A. Removing the inference server entirely. The correct answer is A. How precision quantization, continuous batching, and efficient YAP cache paging, as in NCA-GENL, raise throughput and cut tail latency under load. Question 30. Which features of written by NCA-GENL help production die serving? Select all that apply. Option A. Dynamic and continuous batching. Option A. Multiple framework backends and model ensembles. Option A. Page YAP cache and quantization support. Option A. A requirement that every request use a unique model copy on its own server. The correct answers are A and A. Batching, multiple backends, ensembles, page YAP cache, and quantization make written by NCA-GENL strong for production. Where request dedicated servers would be wildly inefficient. Next section. AVE and AVE application development. Question 31. While AVE assistant returns answers that ignore the retrieved documents and state incorrect facts. That is the most likely issue to investigate first. Option A. Poor retrieval relevance and by or weak grounding in the prompt. Option A. The human fan speed. Option A. The monitor resolution. Option A. The color theme of the name. The correct answer is A. If answers ignore context, the retrieved chunks may be irrelevant, embedding by chunking issues, or the prompt may not instruct the model to rely on them, both common AVE failure modes. Question 32. Which dimensions are commonly used to evaluate a AVE system's answer quality? Option A. Faithfulness, grounding, and answer relevance to the question. Option A. Clock speed and fan able. Option A. The number of monitors connected. Option A. The file extension of the documents. The correct answer is A. AVE evaluation focuses on faithfulness, is the answer supported by retrieved context, context relevance by recall, and answer relevance, often measured with frameworks and human review. Question 33. Which factors can cause poor AVE answers? Select all that apply. Option A. Hunks that are too large or too small. Option A. Weak or mismatched embedding model. Option A. Relevant context exceeding the model's context window. Option A. Missing any retrieval at all. The correct answers are A and A. Bad chunking, weak embeddings, retrieval misses, and context window overflow all degrade AVE. Retrieval itself is the mechanism that grounds answers. Next section. Data preprocessing and feature engineering. Question 34. How can the choice of tokenizer materially affect an entire performance? Option A. It determines how text is split, affecting sequence length, vocabulary coverage, and rare word handling. Option A. It changes the human's clock speed. Option A. It sets the screen brightness. Option A. It encrypts the model. The correct answer is A. Tokenization affects how many tokens text becomes, caused by context, how well rare or non-English words are represented, and ultimately model quality and efficiency. Question 35. Which is a reasonable strategy for treating extreme outliers in a numeric feature? Option A. Tensorizing by clipping or applying a log transform after investigating them. Option A. Always deleting them without any analysis. Option A. Replacing them with random text. Option A. Ignoring data quality entirely. The correct answer is A. After understanding their cause, outliers can be capped, winsorized, transformed, for example, log, or modeled robustly. Line deletion risks discarding meaningful information. Question 36. For a time series forecasting problem, how should train by test splitting be handled? Option A. Split chronologically so the model trains on past data and is tested on future data. Option A. Waffle randomly and split. Option A. Does the same rows for train and test. Option A. Vote alphabetically and split. The correct answer is A. Time series splits must respect temporal order to avoid look-ahead leakage. Common approaches include a forward chaining, rolling, validation that always tests on later periods. Question 37. In production, a model's accuracy declines over months because input patterns change. What is this called? Option A. Meta concept drift. Option A. Gradient clipping. Option A. Tokenization. Option A. Overfitting to the test set. The correct answer is A. Data by concept drift occurs when the statistical properties of inputs or the input-output relationship change over time, degrading performance and prompting monitoring and retraining. Question 38. Which of the following are feature engineering operations? Select all that apply. Option A. Reading interaction or ratio features from existing columns. Option A. Winning a continuous variable into ranges. Option A. Extracting day of week or month from a timestamp. Option A. Randomly shuffling the target labels. The correct answers are O and A. Feature engineering includes interactions, ratios, binning, date part extraction, and aggregations. Waffling labels is data corruption, not feature engineering. Next section. Experiment design. Question 39. In an online mobile test for a model change, what is the primary goal? Option A. Compare a variant against a control on live traffic to measure causal impact on a metric. Option A. Do train the model faster. Option A. Do delete the control group's data. Option A. Do avoid measuring anything. The correct answer is A. Bio-testing randomly assigns users to control versus variant and compares a target metric, isolating the causal effect of the change while controlling for confounders. Question 40. That problem does nested cross-validation address? Option A. Obtaining an unbiased performance estimate when also tuning hyperparameters. Option A. Eliminating the need for any data. Option A. Draining without a loss function. Option A. Encrypting the dataset. The correct answer is A. Nested uses an inner loop for hyperparameter tuning and an outer loop for evaluation, preventing the optimistic bias that arises when the same data tunes and evaluates the model. Question 41. Why is setting a fixed random seed important in experiments? Option A. It improves reproducibility by making stochastic steps repeatable. Option A. It guarantees the highest possible accuracy. Option A. It increases the dataset size. Option A. It encrypts the model. The correct answer is A. Fixing seeds for data shuffling, weight initialization, and sampling makes runs repeatable, which is essential for debugging and fair comparisons, though full determinism also needs other settings. Question 42. Which practices improve the reproducibility of their experiments? Select all that apply. Option A. Fixing random seeds. Option A. Decoding library versions and environment. Option A. Tracking hyperparameters and data versions. Option A. Hanging the code arbitrarily between runs without logging. The correct answers are O and A. Weeds, environment by version pinning, experiment tracking, and data by version control all aid reproducibility. Then logged ad hoc changes undermine it. Next section, nodal evaluation and metrics. Question 43. Towering the classification decision threshold generally has which effect? Option A. Increases recall but tends to decrease precision. Option A. Increases both precision and recall to 1 automatically. Option A. Has no effect on the confusion matrix. Option A. Changes the number of model parameters. The correct answer is A. A lower threshold labels more cases positive, catching more true positives, higher recall, but also more false positives, lower precision, the classic precision recall trade-off. Question 44. That is a key limitation of perplexity as an evaluation metric. Option A. How perplexity does not guarantee factual or task useful outputs. Option A. It can only be computed for images. Option A. It requires no model at all. Option A. It measures with temperature. The correct answer is A. Perplexity reflects how well a model predicts text statistically but not whether outputs are correct, helpful, or aligned, so it is complemented by task and human evaluations. Question 45. Then is the one score particularly preferred over accuracy? Option A. In imbalanced datasets where both false positives and false negatives matter. Option A. Then classes are perfectly balanced and errors are costless. Option A. Then there are no labels. Option A. Then measuring over throughput. The correct answer is A. For one, the harmonic mean of precision and recall is informative on imbalanced data because it penalizes models that sacrifice one of precision or recall. Question 46. Which metrics are appropriate for evaluating ranking by retrieval systems? Select all that apply. Option A. Linear reciprocal anchor. Option A. Normalized discounted cumulative weighing error. Option A. Recall. Option A. Mean required error of pixel values. The correct answers are O and A. Recall at K and precision at K evaluate ranking by retrieval quality relevant to A retrievers. Pixel level is unrelated to ranking. Next section, data analysis and visualization. Question 47. A pair plot scatterplot matrix is most useful for what? Option A. Visualizing pairwise relationships among several numeric variables at once. Option A. Drawing a single time trend. Option A. Displaying a hierarchy. Option A. Rendering audio. The correct answer is A. A pair plot arranges scatter plots for every pair of selected variables with distributions on the diagonal, helping spot correlations, clusters, and outliers across features. Question 48. Then is plotting data on a logarithmic scale especially helpful? Option A. Then values span several orders of magnitude or are highly skewed. Option A. Then all values are identical. Option A. Only for categorical labels. Option A. Wherever log scales are invalid. The correct answer is A. Log scales compress wide-ranging or skewed data, revealing multiplicative patterns and making both small and large values readable on the same axis. Question 49. Which practice can make a chart misleading? Option A. Truncating the y-axis so small differences look dramatic. Option O. Labeling axis clearly. Option A. Including units and a legend. Option A. Using an appropriate chart type. The correct answer is A. Starting the y-axis above zero, truncation, can exaggerate differences. Honest visualization uses appropriate scales, clear labels, and chart types that fit the data. Question 50. Which are good data visualization practices? Select all that apply. Option A. Labeling axes and including units. Option A. Using a chart type that fits the data and message. Option A. Avoiding chart junk and unnecessary clutter. Option A. Using 3fx and truncated axes to exaggerate trends. The correct answers are O and A. Clear labels, appropriate chart types, and minimal clutter aid understanding. Gratuitous 3A and axis truncation mislead viewers. Next section, NVIDIA and accelerated data machines. Question 51. That is the main benefit of keeping an entire data science pipeline on the web with NVIDIA. Option A. Avoiding costly web data transfers and accelerating each stage end-to-end. Option A. Eliminating the need for any algorithms. Option A. Guaranteeing perfect model accuracy. Option A. Removing the need for data. The correct answer is A. Running and graph on the web avoids repeated host device transfers, so the whole workflow benefits from web acceleration. Question 52. That does the cut.pandas accelerator provide? Option A. A way to speed up existing pandas code on the web, often with no code changes. Option A. Replacement for the Python interpreter. Option A. Built-in. Option A. Network firewall. The correct answer is A. Cut.pandas can transparently accelerate unmodified pandas workloads on the web, falling back to one when needed, lowering the barrier to web acceleration. Question 53. In which situation is web acceleration with NVIDIA likely to help? Option A. Very small datasets where overhead dominates and one is already fast. Option A. Massive datasets with heavy aggregations. Option A. Large-scale joins and group bys. Option A. Training and models on large tabular data. The correct answer is A. For tiny datasets, data transfer and kernel launch overhead can outweigh web gains. NVIDIA shines on large, parallelizable workloads. Question 54. Which are advantages of web accelerated data science with NVIDIA? Select all that apply. Option A. Faster NAND on large datasets. Option A. Familiar pandas by scikit-learn like OBS. Option A. Ability to keep data on the web across pipeline stages. Option A. Making small hub files load slower. The correct answers are O and A. NVIDIA speeds large-scale NAND by offers familiar OBS and keeps data on web. Slowing down workloads is the opposite of its purpose. Next section. Alignment and reward. Question 55. In reward, reward hacking refers to what? Option A. The policy exploiting flaws in the reward model to get high reward without truly desirable behavior. Option A. A hacker stealing the reward model. Option A. Deleting the reward model. Option A. Increasing the web clock speed. The correct answer is A. Because the reward model is an imperfect proxy for human preferences, the policy may find loopholes that maximize reward while violating intent, mitigated via alert penalties and better reward models. Question 56. That is the purpose of the alert divergence penalty during reward policy optimization. Option A. To keep the fine-tuned policy from drifting too far from the original reference model. Option A. To increase the learning rate automatically. Option A. To tokenize the prompt. Option A. To compress the model. The correct answer is A. While that penalty between the updated policy and the reference model discourages the policy from straying into degenerate or off-distribution behavior while still increasing reward. Question 57. Which are genuine challenges in aligning bias with human values? Select all that apply. Option A. Human preferences can be inconsistent or hard to specify. Option A. Reward models are imperfect proxies that can be gamed. Option A, balancing helpfulness with harmlessness. Option A, alignment is automatically solved by adding more parameters. The correct answers are O and A. Alignment is hard because preferences are noisy, reward proxies are gameable, and helpfulness versus safety can conflict. Simply scaling parameters does not solve it. Next section. Trustworthy Win Ethics, OS and Safety. Question 58. That does differential privacy aim to provide when training on sensitive data? Option A. Mathematical guarantees that limit how much any single individual's data influences the model. Option A. Faster training on a Option A. Higher model accuracy automatically. Option A. Larger context windows. The correct answer is V. Differential privacy adds calibrated noise, for example, MVAR, so the model's outputs are statistically insensitive to any single record, bounding privacy leakage about individuals. Question 59. Which approach most directly reduces factual hallucinations in a deployed assistant? Option A. Rounding responses in retrieved authoritative sources A and citing them. Option A. Raising the sampling temperature. Option A. Removing all evaluation. Option A. Shrinking the context window arbitrarily. The correct answer is V. Retrieval grounding supplies verifiable context and citations, constraining the model to supported facts, one of the most effective practical hallucination mitigations. Question 60. Which of the following are potential sources of bias in an entire system? Select all that apply. Option A. Imbalanced or unrepresentative training data. Option A. Historical by societal biases embedded in text. Option A. Waste human feedback during alignment. Option A. The physical color of the server chassis. The correct answers are O and A. OS can arise from skewed data, societal patterns in text, and biased annotations by feedback. The hardware's appearance is irrelevant. That completes the practice test. Review the explanations for any questions you missed, and good luck on your certification exam.